Okay, welcome to 5.1, video lesson number 1 for calculus. This is Mr. Diorio. We've got 3 boxes to do for you, and they are super important because they are the beginning of your understanding of something called antiderivatives and the integral symbol. Okay, so box number 1, let's just dive into this thing right here. Okay, here's the idea. What we have been doing so far in calculus, okay, which we've been getting really good at, is we've been starting with a function and we have been doing all kinds of things where we find or take the derivative and then we end up with the derivative here. So we could start with a function f of x, we find the derivative using a variety of techniques and we end up with f prime or ddx or any other way to represent that. That's what we've done so far. Now, the new stuff, chapter 5, what if we are given a derivative and we need to actually go backwards and end up with the function? That's the basic idea. Okay, so instead of being given the function and finding the derivative, we're now given the derivative and we got to work backwards and find the function. So this is called anti-differentiation, right? That makes sense because if this is called differentiation, then this one's called anti-differentiation. That's no big deal. Also notice something. Notice that anti-differentiation is just the inverse operation to finding a derivative. So they undo each other. And we are familiar with this concept of inverse operations. We've been studying it in functions throughout pre-calculus. Okay, so this is the basic idea. This is what we're going to be doing for this unit. Box number 2, I'm going to give you the official definition, and then we're going to work through a quick example and hopefully make a discovery here. So the definition of an antidifferentiation is the following. So a function, which we're going to call capital F, okay, a function which we'll call capital F, is an antiderivative of a regular function, which we'll call little f, when for every single x in the domain of little f, it is true that the derivative of the antiderivative gives you back the function. So the derivative of the antiderivative gives you back the function. That's not a very useful definition when you're just understanding this stuff. So let's just kind of work backwards and play with this stuff. Let's say that I gave you this. I said, hey, everybody, calculus class, there's a function out there that exists such that when you take the derivative, you get 3x squared. Your job is to tell me what function I was originally thinking of, okay? And hopefully you guys see that you guys came up with, I'll bet the original function was just x to the third, right? Just x to the third, because when I take the derivative of x to the third, I use the power rule and I get 3x squared. That's exactly what we found right there. But there might be somebody else sitting out there that says, wait a minute, Mr. Diorio, I came up with one too. And it was g of x is equal to x to the third plus 5. Well, shoot, this person is correct, because when you take the derivative of this, g prime of s, you get 3x squared, and this of course goes to 0. So this is also an antiderivative of the function, and this is an antiderivative. And then I'll bet you there's somebody else out there who says, yep, Mr. Diorio, I found another one. It's this one. It's x to the third plus 17. Well, shoot, that person would also be correct because h prime of x gives me back 3x squared, which is exactly what we have. So what you're noticing here is that this is it is an antiderivative. This is an antiderivative, and then this one was an antiderivative. So what's happening here is we are creating what's known as a family of functions. A family of functions. And they all look like f of x is equal to x to the third plus c, where c is just some constant, okay? They all look like this. So there are actually an infinite number of antiderivatives if I'm just given 3x squared. Well, that's very interesting. That's going to help us out. So we're going to formalize this, and we're going to give you all the skills to come up with these things on your own later on. But I just wanted you to see that there are many different answers that can give us back the original function. Therefore, there are many different antiderivatives out there, okay? Okay, box number 3 is the most important box in the entire lesson here, okay? So the anti-differentiation process, okay? And the process that I'm talking about is the thing that we just did up above in box number 2, where we were coming up with all those different families of functions. That's the process I'm talking about, okay? So the anti-differentiation process, it has a fancy name, and that fancy name is integration. Okay, so the process by which we find the family of functions of anti-differentiation is basically called integration. Okay, so now I'm going to show you the official symbol and what all this stuff means. Okay, so I don't want you to freak out, but I've given you a beautiful chart. Okay, everything in blue is the math, and everything in red are all the parts that we need to be responsible for. So I'm going to take you through all of the parts one at a time, and I'll write all my new stuff in black. So let's go over the parts of integration, okay? First thing you gotta notice is this symbol right here. This is the indefinite integral sign. And that's basically just telling us that we're doing a process of anti-differentiation. It's a long S. We'll get into this later as to where this comes from and what this means. But right now it's a long S, okay? That's the first thing. That's the indefinite integral sign. Then we have some function, f of x, okay? That's called the integrand, okay? Then there's a dx that follows, okay? Notice that this x and this x match. They don't always have to match. The d is the differential, and it tells you which variable that you are differentiating with respect to, okay? So when we find the family of functions, we're going to come up with the antiderivative, and it's going to be f of x plus c, where c is some constant of integration, and we talked about that up in box number 2. So the antiderivative is what you get on the right-hand side of the process of integration, okay? So this whole thing is called integration. So let me show you an old and some new ways, some old stuff and some new stuff. I'll keep this as big as I can. So before, this is what we were working with, right? We would start with the function x cubed, we would take the derivative, and we would get 3x squared. That's the old way. The new way to represent this would be the antiderivative of 3x squared dx is equal to x cubed plus c. So this is the new way of representing it. Okay, that's the new way of representing it. So we read this stuff as the antiderivative of 3x squared with respect to x. That's how we read this information. It's just the antiderivative of 3x squared with respect to x. Just like this information, we know to read as, well, that's the derivative of y with respect to x. We now have another symbol that we need to know how to read, and this is the antiderivative of 3x squared with respect to x. Okay, that's it for this video. This is the introduction. We're going to use this stuff in the next 2 videos.